This is Chapter 2, Section 5. This is the second video. So the measures of center, if you don't have the original data, you can use the frequency distribution, which is the tables we made in Chapter 1 and in the first part of Chapter 2. So again, if you don't have the original data, because if you do, you just do what we did before, just calculate and you get the exact answers. These are all estimates essentially. So you want to find the frequency and the midpoints of your table and then divide it by the frequencies. That'll give you an estimated mean. And with the median there are two methods. There's the interpolation method, which is using the values in the classes, which is more accurate. The less accurate method is to take the midpoint of the class that the median is would be found basically. And then mode also has two methods. The more accurate method is the grouped data method, which is using the classes themselves, where the mode would exist, versus just taking the midpoint of the class with the greatest frequency, was the less accurate method. So let's take the data for the IQ scores of children exposed to low levels of lead that we've done before, and this is the table we had made in the previous lesson for the lead data essentially. Okay, so let's put this in a spreadsheet and we're going to add in two columns, right? The things that we need to do this are midpoint and frequency times midpoint, essentially the things that we need, right? Alright, let me get rid of that there. Okay, so there we go. Alright, so midpoint, we have to add up the two classes and divide by 2, or the endpoints of the limits of the classes, right? So the midpoint of 50 and 63 is 56.5, right? Add them up, divide by 2. Okay, and then we need to multiply the frequency times the midpoint, and then drag that down. Okay, so this is the formula for mean, the estimated mean from a frequency distribution. So we're going to add up all of those frequency and midpoint products, and add up all of the sample frequencies, which is 78, right? So there's 78 total, right? And we divide those, top divided by the bottom, and we get our answer here. We'll fill this in with something. What's a nice color? How about a green is our answer, right? So there's our estimated mean from a frequency distribution, which we would do if we didn't have the original data. Okay, median. We have the interpolation method and the class midpoint method. Okay, so we need the lower boundary of the median class. We don't have the boundary, so let's add another here. So class boundary, right? So maybe hold the Alt key when you hit Enter, so it goes down a second line, right? Okay, so 49.5 to 63.5, 63.5 to 77.5, 77.5 to 91.5, 91.5 to 105.5, 105.5 to 119.5. That's not going to fit in there. Let's make that a little bit bigger. There we go. 119.5 to 133.5. 133.5 to 137.5. Remember the rule, you go one more decimal place than the actual data. The IQ data didn't have any decimal place because it was whole numbers, so we go one decimal place on the boundaries essentially. Okay, so let's make this a little bit smaller so we can read it. So lower boundary of the median class. So if I look at this, there's 78 values here, correct? So 78 divided by 2, the median would be at the 39th position, right? So where would it actually fall? So if I look here, this is 2 plus, let's actually do this. We'll do insert cumulative, cumulative frequency, right? Okay, so equals this, and then equals this number plus the prior number, we'll drag it down. Okay, so that's my cumulative frequency. So there's 2 in this one, so this one plus this one is 14. These three together is 36. So the 39th value, right, because there's 78 values, so 39's in between, is going to fall in this class here. So this right here, if we fill this in, is the median class essentially, because 78 values, halfway in between would be the 39th position, right? Because there's 78 positions. Because we don't know what the original data was, we just don't know. We just know they fall into here. So the 39th is the middle, right, of 78. So it falls into here somewhere, right? because this plus this is 36, so 37, 38, and 39 fall into here essentially. Okay, so the lower boundary of the median class, so this is the median class, so the lower boundary is 91.5. The cumulative frequency before the median class would be 36, right? Because this is before the median class, 36. The frequency of the median class is 28. The width of the median class, this is where people make mistakes. They look at this and go 105 to 92. Whoops, that is not correct. Do not do that. That gives you 13. The answer is not 13. The answer is plus 1. The answer is 14, right? Remember that when we did width, right, how we calculated it? Let's say I have 1, 2, 3, 4, right? So my class width is 1 to 4. If I do 4 minus 1, that's 3. Again, if I do 4 minus 1, that's 3. There is not 3 numbers there, there's 4. Let's say I do 5, right? If I do 5 minus 1, that's 4. There's not 4 numbers there, there's 5 numbers there, right? You can't just simply subtract them, that's the difference, right? The width is this number, right? Plus 13 more numbers will get me to there, right? So 50 plus 13 more numbers gets me to 63. So that's a width of 14 essentially, right? Which would have come from your width calculation. All right, and then this is 78 divided by 2, right? Because we have 78 values here, obviously, right? All right, now we can actually do the interpolation method. All right, so lower boundary, right? Plus parentheses, right? Common mistake. N divided by 2 minus the cumulative frequency, close paren, right? So that's the numerator there, which is why we need the double parenthesis, divided by the frequency of the median class, close paren, times h, which is the width, okay? And I get 93. Okay, so the class midpoint method, all I have to do is look at the class here and get the midpoint, which is 98.5. And that's it, right? This is more accurate than this one because this accounts for sizing. This one does not, basically. Okay, so a lot of times they teach this one in high school, although it's not as accurate. Okay, so let's do the modal one, right? So the lower boundary of the modal class. Okay, well, the modal class is the one with the highest mode. Or highest frequency. Well, what happens to be the same one? Is it always the same one? No. So the median class and the modal class is not always the same class. In this case, it happens to be because the fact that this has the highest frequency, which is also happened to be where it falls in the middle as far as the count also. So it happens to be the same. So the lower boundary of that class is the 91.5, correct? All right, frequency of the modal class is 28. The frequency before the modal class is 22. The frequency after the modal class is 10. And the class width, of course, that's the same as before, 14. That doesn't change, right? Okay, so the formula is LM plus parenthesis, because I have a numerator there with two things, FM minus FB divided by parentheses 2 times FM minus FB minus FA close paren, right? So the whole numerator has parentheses, the whole denominator has parentheses, and that whole thing is multiplied by H. So multiply by H, and I get 95. Okay, so all I have to do is, for the modal class, take the midpoint otherwise. So this is the modal class, which happens to also be the median class in this case, right? So the midpoint is 98.5. Okay, which again is less accurate, but they do that a lot of times in high school. Okay, so remember, class midpoint method, figure out where the middle falls. So, find where it falls. After 39, falls into there. Class midpoint method, whichever one has the highest frequency, essentially. Okay? All right, so if we go back to the notes, all right, we essentially found the midpoints and the frequencies. We multiplied them and divided, and we got the mean, right, x bar. Okay, the interpolation method, we had to figure out a whole bunch of different things, right? Oops. Copy. There we go. Okay, and then we got 93. Otherwise, the midpoint was 98.5. Okay, and the mode, same thing. We had to figure out a whole bunch of different things, and we got 95. Otherwise, it's 98.5 for that. And again, these are all estimates, right? Because you use these, right? You use these if you don't have the original data, or if I just ask you to as part of a question.